Hello, I'm John Fields, and we're going to start a series of instructional videos on repairs of audio equipment, just things that come into the shop, and see how it goes. Today, we're looking at a Mackie 1202 VLZ Pro mixer. This is a mixer that they sold a few 100,000 of. This one was made in the 12th week of 2003, according to the date code here. And the person that brought it to me said that it doesn't power on. So we're going to try to diagnose it and troubleshoot it today. So the first thing we're going to do is plug it in and see what happens. Now, I have to tell you, don't open up any line powered equipment unless you know how to work on electronics equipment. Any of this stuff should really be done by a pro, but if you're a hobbyist, you can dive in there and see what you can do. But always be really careful to be respectful of the electricity and be as safe as you can be, because you don't want to get hurt doing this stuff. Okay, with that said, let's flip it on. And no lights. The power LED's off, so now we're going to have to see what we have here. There's no fuses or anything like that on the back. There's a fuse right here, but we'll have to pop that fuse out and see what it looks like. Okay, so the fuse clip has like a little ridge on it right there, and you just take a flathead screwdriver, just kind of push down and scoot it out like that. Okay, I'm looking at the fuse here, and as you can see, the element looks like it's probably good. Just to be 100% sure, we can measure it with an ohm meter. And let's just see if the fuse measures good. And on our ohm meter up there, you can see that it's measuring really low. So the fuse is good. So let's put the fuse back in. And the way you do that is just the opposite of the extraction there. Okay, and it snaps in. All right, so now we got to take it apart. It's got 3 screws here, 3 screws here, no flange screws. So it looks like it's pretty straightforward. Now these are what are called thread forming screws. So when you take them out, you can do it with a power glider. But when you put them back in, you have to be real careful that you don't set the torque on your driver too high, or you will strip those screws. So we don't want to do that. And we're going to take this front bumper off for good measure, because it looks like it probably are close. Alright, now let's see what we have going on here. Alright, we got 5 more screws on the bottom that we need to take out. Alright, now that we got that, let's see if we can, one more right here. Just on the one side there. So now, I can take this off. Alright, now that's nice and clean. Everything's all on this one assembly right here. So we can just kind of gently set this down on these knobs. Alright, now that we have it apart, we're going to do a couple of things. I don't have a schematic for this, so I'm just going to look to see just a couple of basic things. So it goes to a linear power transformer right here, so it's possible that can be opened. It also has a ground link of some sort here. So really the first thing you do is you have to determine whether or not you're getting AC power. So I'm going to pop this little transformer out right here. And it's held on with a nut and bolt, so you have to be careful to contain that. Alright, and the same thing over on this side. I'll probably grab that with some pliers. Alright, put those over here. Then we'll take the power transformer out, or what I assume is a new metal shield around it to stop hum. This shield it's made of steel, but it's called grain-oriented steel, and the steel has all the grains running this way. And what that does is it stops this circuitry from picking up the hum from this cheap little transformer here. Mackie was really good at doing cheap designs, and they had to do things like that to eliminate hum to get around the cheapness, and you know, it's kind of a cool thing that most people don't really know about. Okay, so here's our power transformer. It looks like it does have a connector on it over here, which is good. And there's a phantom power switch for another part of it on the back down in here that turns on an actual secondary of the transformer to apply phantom power. So that's also something that we can probably look at. So the first thing we want to do is determine whether or not we have AC power coming into the unit. So I'm going to put like an insulator, just something to shove under this transformer so I can power it on without shorting to any of that circuitry there. And we're going to start poking around a little bit and see what we can find. Okay, so the first thing we want to do is, and this is where your safety comes into play, you're going to plug it in with the power turned off. Alright, now I'm going to turn it on. And I already know it's not doing anything, so let me get my meter here and go to AC volts. I'm just going to stick one side in the chassis here just to give me a ground reference so that I can just kind of poke around and see what kind of voltages I'm getting with reference to ground, because when you get to the DC side, that's all that really matters. So here we have 121 volts AC. So it's getting to the plug. So that means that the disconnector is good. Now, when it comes over here to the power switch, we want to see if the power switch is good. So we'll go from this side of the power switch. And now when the power switch is in the on position, you simply go to the other side of the power switch to see if the power switch is working. And the power switch has 120 volts on both sides, so it is working. Now, since we know that we're getting AC voltage into the transformer, we're going to go over to the secondary of the transformer and see if we're getting the secondary AC voltage. Now, since I don't have a schematic, I don't know what these taps are, but looking at these wires, and this is on, by the way, looking at these wire colors, I can deduce that these red ones are most likely a center tap secondary, and the brown and black are probably another center tap secondary. The brown's probably some voltage, and this black is probably ground. So let's test that theory real quick. You'll have AC on this side, so 105 millivolts AC reference to ground. 112 millivolts AC reference to ground. 0. So this is actually a ground right here, and this is, you can see the stripe here. Actually, that's brown. So brown, black, brown is probably its own secondary. So ground, nothing, nothing. So we're not getting anything coming out of just a power transformer. All right, so since we think the power transformer is probably bad, we're going to remove as much of that as we can. So first we turn it off, unplug it, and we didn't measure any AC over here, so we can pretty much deduce that there's not going to be any DC in the circuit right now, so I'm not going to bother discarding anything. Now this is low voltage equipment also. You can see the power supply capacitors have a 25 volt rating. So now I'm working on this without a schematic. I know that there's not more than 25 volts per side on these high voltage rails. So you're not in terrible danger if anything's charged up in here and you open it. But if it were a tube amplifier, you would want to short these or through a resistor or something to make sure that there were no voltage on them. So anyways, now we have this here. I'm going to cut this wire tie off so that we can see what our transformer secondaries are. Now, I'm just testing this to see how far I can get without looking up a schematic, because I really don't want to spend a whole lot of time on this repair. It's not very valuable, you know, and if you're charging someone $75 to $100 an hour on the low end, you probably couldn't get $100 for this at a pawn shop. So, you know, you have to ask your customer, how much money do you want to put into it? Is, you know, what is it worth to you to fix this piece of equipment? So in this case, I'm doing it for a friend. So he told me I could film it, you know, and he'd be cool with that. So I thought, well, okay, I'll spend some time on it and see if I can teach someone how to troubleshoot without a schematic. Anyways, we're assuming that the power transformer is open. So now to that end, let's see what we have coming off of this power transformer. We have these primary wires right here, and then these secondary wires coming out right here. Now if I untwist these, I can see that there's a secondary there. This is coming over to here. This is only going through that switch, which turns the phantom power on. So that phantom power switch, all it does is energize another secondary. So we can totally test this without pulling it completely out. Now, we just had it in circuit and we tested it, and we didn't really measure any voltage on it or anything. So now what we're going to do is we're going to take it out of circuit and we're going to measure it, and we're going to see what happens. So I need like a weight of some sort to kind of put on this wire to hold it down. I'll use that. All right, so now I'm going to plug it back in. I'm going to turn it back on. And I'm going to take my meter and I'm going to go straight across those secondaries and see what I can see. So from brown to brown, I would totally expect there to be some voltage if it were unloaded. And I'm measuring flat, nothing. Now, from brown to black, nothing. Now, if I look over here at this red tap, this is two sides of that. There's basically nothing there. Okay, so now it's time to see if the transformer has an open primary. Is there an open winding on this transformer that's causing it not to do the thing? So the easiest way to check that is to unplug it. And then you go straight here with the power switch on and you measure and see if there's continuity on the primary of it, because the primary is only hooked up through the fuse and the power switch. So what I'll do is I'll go over to ohms for an ohm meter. First I'll measure it with the power switch off for a reference to see if it's a true short or not. Now it's wide open, as it should be. Now, when I flip the power switch, I would expect this to go to a very low impedance of some sort, like I was measuring a fuse. I don't see that. So we're thinking that the power transformer is probably going to be open. Now, just to be 100% conclusive on that, I'm going to measure it before I desolder it, because I don't want to take nothing out if I don't have to. I'm going to go right down there to the terminals, the gray and the yellow primary terminals, and I'm going to see if I can measure anything there. And if I don't, this sucker's open and it has to be replaced. So I'm going to check my zero, like I'm an old guy or something. I've got 0. Now I know that my meter's measuring 0. I know that I'm on the primary. And as you can see on the meter, it's open. That transformer's bad. I got to find a replacement for it. So, anyways, what I'm going to do next is I'm going to Google Mackie 1202 VLZ Pro. I'm gonna get on there and I'm going to see if I can't find Mackie Designs part number 080007-00, which is going to be a 120 volt transformer made by a company called Ultratech. So that should be pretty straightforward to find online and to fix. Now, the fact that it doesn't have, the fact that the primary is open tells me one of two things. Since that primary is open on this transformer for sure, then we know that it either has a thermal fuse on the inside that's open, that's failed, and no longer resets, or it has a one-shot fuse, which is real common in cheap transformers. And a one-shot fuse opens and then that's it. You replace it if it goes bad. Now the other thing is, what took it out in the first place? Now there's a chance that there was a short in the circuit somewhere that took the transformer out. So just right quick, before we give up on this, let's take our ohm meter to ground. Let's go over here on this power supply plug, and let's just see if we have any dead shorts to ground. Okay, that's a very high impedance, so it's not that. That's a very high impedance, so it's not that. Same. So basically we're measuring the input of capacitors. Now this wire here, we'll remember that it was brown, black, brown on the connector. That generally indicates that that black one on the same winding is the center tap. So that would probably be connected to ground in most typical power supply circuits. And you would expect that to be ground. So over here we have the other side of that winding, and it's not shorted. So we can deduce from what we read here that the secondary is fine and that the transformer didn't fail because of a catastrophic short somewhere else in the amp. So more than likely the primary opened because this was sitting somewhere on for years and years and years, and the transformer, being a really cheap part, just couldn't take the heat, and the fuse opened up on the inside of the transformer. So my next step is going to be to go try to find one of these, and basically I'll sorry, iron's not working. Basically I'll desolder this transformer, pull it out, verify that it's open out of circuit, and then try to find a replacement for it and put it in there. Anyways, I hope this has helped some of you burgeoning repair people out there, or possibly someone who's worked on a Mackie mixer before. And I'll be posting more videos soon with lots of nuggets and information about things that I've learned over the years working on this kind of equipment. And anyways, please like and subscribe, and we hope to see you here again soon. Thank you.